This is my weekly video. This is my week 4 video log for my independent study. This week I worked on implementing oriented bounding boxes as well as getting collision between oriented boxes and spheres working. What you can see from this demonstration is I've got a number of boxes moving around the scene. Each of these boxes has a slightly different scale, it's different shape and size, and they all rotate. As they rotate, you can see that they each have an axis-aligned box wrapping them, and the axis-aligned box is automatically updated to correctly fit the oriented box. You'll also notice that there are a couple of spheres moving side to side within this area, and the spheres all have an axis-aligned box that's fitted to them as well. One of the things that I updated this week was I improved the visualization for collisions. So you'll notice now that all of my collidable volumes have both a white or have an outlined axis-aligned box, as well as the collider itself is now axis-aligned. So I've got visualization for spheres now. I don't have meshes for them because my mesh loader is actually very buggy, and so it crashes when I try to load the sphere mesh. But you can see I've got a wireframe for the spheres currently. And when a collision is detected for any volume, so if two AABBs intersect, the AABBs highlight red, and if two of the colliders intersect, then they're highlighted red as well. So now it's much easier to tell where a collision is happening. And so if you watch, you can see that collisions between AABBs or between oriented boxes are detected correctly, as well as collisions between spheres and collisions between spheres and oriented boxes. So that's all working. Previously, when I was doing my collision performance tests, I was using nothing but sphere colliders, but I wasn't actually doing any of the sphere tests. I hadn't realized it at the time, but because my code for doing bounding volume hierarchies was such a mess, I didn't realize that I had completely stubbed out those tests. And so when I was testing two colliders, I was only testing the AABBs, and I was never testing the underlying colliders. So now that I've got both sphere colliders and oriented box colliders, the collision test times are taking longer, but that's also giving me a better idea of what the performance profile is, so it gives me a clearer view of what optimizations I need to start making. One of the other things you might notice is going on here is whenever a sphere is colliding with an AABB or is being tested with an AAB or with an oriented box, there's a little blue dot. It might be kind of hard to see in the video, but let's see, wait food and Cayman. It's hard to see. Oh, so you can see right here maybe that there's this little blue circle right on the edge between this sphere and this oriented box, and as the two move, the sphere, the little connection point, moves to trace the point of contact between them. So that would represent the point of contact, and once I'm passing that information through in the collision callback. So right now the collision callbacks only track which pairs of entities are colliding. Once they also track more information about where the collision happened, what the point of contact was on each of the objects. So that value will be passed around. And right now that value is only being visualized for collisions between spheres and oriented boxes, because you have to calculate that value in order to determine if the collision is happening. But once I'm doing things like, I'll also be able to calculate that for oriented box collisions, and especially for sphere collisions. That's pretty easy to do. So that's it for what I got done this week. Next week, I expect I'll be primarily working on my midterm document. After that, I'd like to spend some time working on getting mesh collision working. However, I think that's probably a bigger task than is worth it at this point, just because my support for loading meshes is pretty weak. As evidenced by the fact that I can't load the sphere meshes. So it might be worth it to take some time to improve the mesh loading code so that I can get mesh collisions working. But I think it'd also be worthwhile to spend more time working on my spatial partitioning and either better handle dynamically sizing the grid, because the grid is set up to be a 1x1 grid, which was fine when all the objects were 1x1, but now I've got objects that dynamically resize. Something needs to be done with the grid to better handle those cases. And I could potentially want to... The other things that I want to look into are the hierarchical grid solution, because the whole point of the hierarchical grid is to handle cases where there are objects of wildly varying size, which is now starting to be the case in this example. Also, I'd like to look into multi-threading for performance improvements, and also I'd like to just try to improve the single-threaded performance of the of this collision test. Yeah, so that's it for this week. I will see you again next week.